It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming Doing Nice Coffee.
Hi guys, welcome to this next video. This one's going to be all about calculating oxidation numbers. And this is really useful if you're going to be doing anything involving redox, or if you want to understand if something's undergone oxidation or reduction. There are some other videos, but I strongly recommend you watch this one first before you watch those other ones. Really give you an idea of what's actually happening. So what I'm going to do for oxidation numbers, I'm going to introduce you to 4 rules. Okay, and the best way you can do this is just take each rule one by one, okay, and practice it before you move on. So the first rule I'm going to talk about is that the oxidation number of any atom in a diatomic molecule is 0. Okay, now what I mean by that is if you have an atom that's just by itself with no other atoms combined to it, the oxidation number of that atom is going to be 0 if the overall charge is 0. So I'll show you. In chlorine, Cl2, all we've got is chlorine atoms. It has no charge, so the oxidation number is equal to 0. Okay. If we have fluorine, F2, again the oxidation number is equal to 0. Hydrogen, H2, oxidation number is equal to 0. Okay. It doesn't even have to be a diatomic molecule like these ones. If you've got sulfur, which you can react with other things, it's by itself, no charge, the oxidation number is equal to 0. So straight away, if you see something just by itself, if it's carbon by itself, or if it's sulfur, if it's a diatomic molecule, okay, as long as the whole thing has no charge, the oxidation number is equal to 0. So that one's pretty straightforward. The next rule relates to ions. So if you've got an atom that is charged, okay, the oxidation number of an ion is equal to its charge. Okay, so if you've got any charged one, so let's look at this time, we've got chlorine, Cl minus, okay, the oxidation number is -1. If you've got oxygen, which has a 2 minus charge, the oxidation number is -2. Now notice how you actually write the convention for oxidation numbers. You have the charge and then the number. Whereas normally if you're talking about the actual charge on the atom itself, you have the number and then the sign. So it's the opposite way around. If you have aluminium, Al3+, the oxidation number is +3. Okay, so again that one's pretty straightforward. If you've got an ion, alright, with nothing else combined to it, so just one atom in there, the oxidation number is exactly identical to the charge of that ion. But most of the time in chemical reactions, we don't have things that are just that simple. So what we've got is we've got a number of atoms bonded together. So this is where I introduce rule number 3. The oxidation numbers of all atoms in a neutrally charged species add up to 0. So what we mean by that is if you've got a formula and the overall formula has a charge of 0, the oxidation number of each of those atoms in there when you add them all up must equal 0 as well. So we'll start with a simple one. One like carbon dioxide, CO2. Okay? Alright. What we're going to be looking at is working out the oxidation numbers of each of them. Now, what you may not always necessarily know is what one to start with. So I'm going to give you a couple of tips just to keep over on the side here to always remember. Oxygen always has an oxidation number of -2. Okay? Hydrogen has an oxidation number of +1. Now there's 2 exceptions to that, which I'll cover after I've gone through this. But if you can always remember, oxygen is -2, hydrogen is +1, that will keep you in good stead when you're trying to work out the rest of these. So I'm going to circle these in red, and we're going to leave that over on the side while we go through and do these. So in this one, our oxygen has an oxidation number of -2, because that's what we've always got here. So we write that above the oxygen, -2. Now what we do is overall carbon dioxide has no charge. So we have a look at the charge here. 2 times -2 gives us -4. Alright, so to get from -4 to 0, our oxidation number here must be +4. So when you add them all up, a +4 and 2 lots of -2, overall, that gives us a 0 oxidation number. So the carbon had an oxidation number of +4, oxygen -2. That's what this rule is trying to tell us. So let's have a look at another one. Alright, let's look at sulfur trioxide, SO3. Well again, we know oxygen is -2 in one of our rules. So we put that above the oxygen, -2. The sulfur must add up, must have an oxidation number so that the whole thing equals 0. So we've got 3 lots of -2 is -6. Alright, so to cancel out -6, we need plus 6. Alright, so the sulfur here has an oxidation number of plus 6. Alright, let's look at another one now where perhaps you've got a couple of things together. So let's look at Cl2O7. Alright, here we know oxygen again, following our rule, is -2. So we've got 7 lots of -2. So overall here, alright, we've got -14, and we obviously want to add something to it, so the opposite of that is +14. However, what we've got is 2 chlorine atoms here, 2 in the charge, and we've got +14 in total. So what we need is 2 lots of +7. So in this case, the chlorine has an oxidation number of +7. So we just divided the number of atoms that we had by the overall oxidation number we need to get to. Still cancels out, so it's all 0. Okay, so that one's pretty straightforward. What I'm going to do now is just show you the 2 times when oxygen, and also the 1 time each, or 2 times total, where these are not -2 or +1. The first one revolves it around for oxygen, okay? And the only time it's not -2 is if you have, sorry, I'll get a new pen, is when you have hydrogen peroxide. So for oxygen, the only time where it's not -2 is where you have hydrogen peroxide, H2O2. Okay. Now in this case, we know hydrogen is +1, so that's +1 there. So overall, that gives us +2 here. So the oxygens here must equal -2 in total. But we've got 2 of them, so if it was normally -2, it would be -4, which it can't. So here, the oxygen is actually -1. And that's the only time you'll find oxygen when it's combined with other things, which doesn't have an oxidation number of -2. The hydrogen is always +1, except if you combine it with a metal. So if we've got something like sodium hydride, which can happen, right? Metals always lose electrons. So the charges on metals are really easy to work out for their oxidation numbers. Sodium's in group 1, so its oxidation number is going to be +1. Magnesium's in group 2, oxidation number +2. Aluminium group 3, oxidation number +3, because they will always lose electrons. So in this case here, if the hydrogen was +1, +1 and +1 will give us overall +2, but this has no charge. So the hydrogen here must be -1. These are called hydrides. So they are the only time you will get a hydrogen with an oxidation number that is something other than +1 if you combine it with a metal. And the only time you get oxygen with something other than a -2 is when it's hydrogen peroxide, and it'll be -1. Alright, I'm going to introduce you to the final rule. Okay, and the final rule states that the oxidation numbers of atoms in a polyatomic ion must add up to the charge of the ion. Now, polyatomic means many atoms, okay? So if you've got lots of atoms combined together and it's ion, so it's charged. So it's many atoms together with a charge. The overall oxidation number must equal the charge of the ion. So this is kind of the similar as rule 3, where we added them all up, and so they cancelled out and had no charge. This time we're just equaling the charge of the ion. So I'll start you off with a couple of simple ones. Okay, so I'm going to start off with SO4 2-. Alright, so sulfur, so the sulfate ion, we know oxygen's -2 in there, so we've got 4 lots of -2, which gives us -8. Okay, overall, alright, we need to get to -2, which is what the charge is. So the overall oxidation numbers all added up together must equal the charge. So to go from -8 to -2, we need to add 6. So the oxidation number of the sulfur is +6. Similar to what we were doing before, except instead of adding it all up to 0, you just add it up to equal what the charge is. Okay, so let's have another one. Let's look at... Okay, so let's have a look at another one. This time we're going to go PO4 3-. So each oxygen is -2, just following our rule. 4 lots of -2 gets us -8 again. This time overall, we're trying to get to 3-, alright, or -3. So to go from -8 to -3, we need to +5 this time. So the oxygen, sorry, the phosphorus has an oxidation number of +5. Okay, you can do it with other charged species as well. So even if we have something like the hydroxide ion, OH with a 1 minus, okay, we know oxygen is -2, hydrogen is +1, just following our rule because it's not hydrogen peroxide. -2 plus 1 gives us -1 overall, so it still follows that rule. If we have lots of atoms together, I'll show you that. Okay, so let's say we've got dichromate, which is Cr2O7 2 minus. All right, oxygen's -2, so 7 lots of -2 gives us -14. Overall, we're trying to get to -2. So -14 to -2, we need to have +12. However, this is one of those situations again where we've got 2 chromiums here and we need to get to +12. Alright, so 2 into 12, alright, is 6. So the chromium here is +6. Alright, what do you do if you've got a number of them together, like the bicarbonate ion? Well, you just follow your rules. HCO3 minus, okay, oxygen is -2, we know our hydrogen is +1, so 3 lots of -2 is -6, and +1, alright, equals -5. Overall, we're trying to go to -1, -5 to -1, we need to add 4, so the, on the carbon, the oxidation number is +4. Okay, so hopefully this has been fairly straightforward for you to follow. My advice is that you just make sure you write down those 4 rules, practice them, alright? And like I said, when we get to looking at oxidation and reduction reactions, being able to work out the oxidation numbers really easily. Remember, you write them up the top with the sign first, plus or minus, and then the number, and it's really easy to work out then if something's undergone oxidation or reduction. Okay, hope it helps. Once again, if you've got any questions, ask. Thanks guys.